Similarly, now we are moving on to next chapter 10, mechanical properties of fluids. Okay, so last classes you have shared with me some of the properties of fluids. So fluids means, what do you mean by the fluid? What do you understand by the word fluid? Achyut, what do you mean by the word fluid?
Ma'am,
What do you
I
mean?
took the wrong notes, ma'am. Can I just go and take the notes?
Okay, fine. Go, no problem. Atul, what do you mean by the term fluids?
Gases and liquids.
Gases and liquids all together, we call it as fluids. Okay. Nandana, why do we make a common group, liquids and gases, which make both of them to grouped in a one single group? Can you tell me some of the features why gases and liquids are known as fluids?
The intermolecular space is more.
Yes,
The
okay.
attraction between the particles is less.
Okay. Then, what
They're
else?
more loosely packed.
They are loosely packed. Okay. What else? These are, do you think these liquids and gases have the same intermolecular space, Nandana?
No, ma'am.
No. Okay. Do they have same intermolecular force of attraction?
No, ma'am.
No. Then what we make them to call it as fluids together? There is a difference between the intermolecular space and all those things. Clear? So, but
Yes, ma'am.
still we call them in a single group fluids. Something is which is similar to both of them. Can you just guess the word fluids? FL, something you will get it from that clue. Which make them to known as fluids. Okay. In the molecular space, okay, they are loosely packed, but liquid is less loosely packed, but the gases are more loosely packed. There's a difference between both of them, correct? And your intermolecular force of attraction is not same between the liquids and between the gases. So still, we call them as a fluids. Gauri, any idea?
No fixed shape.
Both of them both of them don't have a fixed shape. Okay, one more point, Aditya, can you think about the word which is similar between them? Some similarity is the one which is making into one single group. So Gauri already gave me they don't have fixed shape. Correct. It's one of the similarities. That means whichever container we take, the liquids and fluids, gases will take the shape of the container. Okay. Tell me. One more point. That's what I look at. Fluids. The word FL. You will get something very simple. No one is getting. Tell
They
me.
can flow.
Yes, correct. Exactly. Okay, they can flow. That is the word is fluids. Okay. Mainly why we call it them fluids. Solids cannot flow. You already know that. If you wanted to make the solid to flow, you have to either convert it into liquid state or either convert it into gas state. Clear? So why we call them as fluids? Because they can flow. They can flow from one place to another place. So that is the feature mainly which is making them to make them in a single group. Okay, fluids. So the word fluid is coming from the word flow. Okay. Similarly, they don't have a fixed shape. Whichever shape we fill it, they will spread in that. That you already know. Okay. So now, last chapter we were talking about solid mechanics. Here also we are going to have fluid mechanics. Okay. So first volume is fully based on the motion, speed, velocity. So similarly, we are coming to certain quantities related to fluid alone. Okay. So that is fluid mechanics. And mainly, the fluids can be, the study of the fluids can be divided into two groups. So the study of the fluids can be divided into two groups. The first group means depending upon the rest position of the fluid, we call the study of the fluids as hydrostatics. You know the statics. Static means stationary. So the fluid mechanics divided into two. First group is known as hydrostatics. Hydrostatics. So that is the first method of study, hydrostatics. What do you mean by static? You know, static means at rest. Okay. So the study of the fluids, study of the fluids at rest, at rest, at rest, or a position. Study of the fluids at rest or a position is known as hydrostatics. Similarly, we have in electricity also, no? Electricity also we have two types. Do you remember which are those two types of branches? Michael, do you remember the two types of electrical studies we have, at rest and at motion? Any idea? 10th standard we have studied two groups of electricity like that, depending upon the rest position of the electron and the moving position of the electrons. Vidur, do you remember what are the two studies? Just like this hydrostatics, we also have in electricity also same. Which are those? Vidur, on the video, please. Again, you are going back to the old routine. No change. So, if you are not changing your ways, this year also going to be like next year. No, last year. Not next year, last year. Okay. You don't see the doorstep of your school. You will be at home only. That's it. So, have some changes. Vidur, can you tell me? I told the study of the fluid at rest is hydrostatic. So, what is the study of the electrons at rest? We have already learned. 9th standard and as well as in our 10th standard, we have studied one branch. Just tell me randomly. What do you think? Very simple question it is.
Electrostatic.
Electrostatics. Very good. And 10th standard, which is the another branch we studied. Difficult chapter, you say? Lot of resistors and parallel and series. What is that study? What is that chapter is known as? Series connection, parallel connection. Do you remember all that? Come up with it. You know it.
Electricity.
Current, electricity. Okay. Yeah. So that is what we have learned, electrical mechanics actually. That is, we have a chapter of electrostatics, that is static electricity, and then we come to the current electricity. So these two chapters you are going to meet in +2. Okay. So let us go back to now. So the fluid mechanics, two branches. The study of the fluid at rest or position is known as hydrostatics. Similarly, the study of the fluids in motion is known as hydrodynamics. Study of fluid in motion. Study of fluid in motion is known as hydrodynamics. Study of fluids in motion. Thus, because of these two features of the studies, we also going to learn a combination of both. Sometimes we take it as a fluid at rest at a particular point, and we take it fluid in motion. Like that, we are going to study a certain theories and some of the expressions related to the learning the velocity, pressure, density, then Bernoulli's equation, kinetic energy, whatever you have learned in first volume regarding the systems. Similarly, we are going to learn the Kinetic energy and all that is for the fluids. Okay. So what is the fluids? Already you have told matter exists in two states, solid state and fluid state. This classification of metal is based on the spacing between different molecules of matter and the behavior of matter. Okay. So why we are dividing? Why we are dividing the solid? Mainly we learn states of matter is three: solid, liquid, gases. But in normal scientific theory, we have only two states: solid state and the fluid state. Okay. So in fluid state is the one which is again divided into liquid and gases. So why we have this segregation between solids and liquids? That is what you have already told me the answer: intermolecular space. In the case of intermolecular space, as well as the behavior. Behavior means it take the shape of the container, it flow. So the main basic principle behind fluid mechanics is one, there are two theory. The first one, write down the basic principle behind fluid mechanics. The basic principle behind fluid mechanics based on two principle. First one is molecular
Ma'am,
theory of matter.
ma'am, can you say again?
Uh, the the basic principle, the basic principle behind the study of fluid mechanics. Fluid mechanics are number one, molecular theory of matter. Molecular theory of matter. Second theory, behavior of matter. Behavior of matter under some stress. Some stress. Okay. So these are the two principles behind the fluid mechanism. One is molecular theory. Molecular theory of matter means it deals with the intermolecular space between the fluids, fluid particles, as well as the intermolecular force of attraction. So that come under molecular theory of matter. Intermolecular force of attraction, intermolecular force of attraction and intermolecular space. This both come under molecular theory of matter. Then behavior of matter. Under this principle, we will learn pressure, density, viscosity, compressibility, surface tension, etc. Surface tension, etc. So these are the basic quantities, the main quantities we learn under this chapter. So first, so these are the two theories, and the fluid mechanics means in solid mechanics, the solid has a proper compactness. Compactness means they are in a particular form. So they have a particular compactness as well as rigidity. They are rigid. Okay, they are not flexible, they are rigid. And in fluids, what's the problem? They don't have the proper shape and they do not possess any rigidity. So these are the difference between the solid mechanics and the fluid mechanics. Solid mechanics, we discuss about compactness and rigidity of that. That is Young's modulus, all that things. In fluid mechanics, they do not possess any rigidity. So we are talking about compressibility, expansion, then as well as the resistive force within the fluids. So these are the main properties we are going to learn. The main properties of fluids are viscosity. Number 1, viscosity. Number 2, surface tension. And number 3, compressibility. The main properties of fluids under fluid mechanics are the main properties of fluids under fluid mechanics are number 1, viscosity, number 2, surface tension, and number 3, compressibility. Yes. Now we are coming to viscosity, compressibility, surface. These are the main 3 things we are going to learn. Before learning this, we have to incorporate certain things we have learned in solid mechanics. The first term we are going to incorporate in order to study this viscosity, surface tension is this pressure. Okay, so you can write the next heading, technical terms related to fluid mechanics. 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 So this is also coming from 9th standard physics. Okay, because in 9th standard physics we have a chapter, gravitation. In that we have learned first technical term is pressure. First technical term is pressure. First technical terms is pressure. Yes. Dia, do you remember what is pressure in your terms? I am applying pressure. When you hammer the nail on the wall, you are applying the pressure. So what do you mean by pressure?
A certain force applied on rubber.
Correct. Very good. A certain force is applied on an object. So we will modify little more. It is a certain thrust. Thrust means THRUS. Thrust acting per unit area. Okay. So what is pressure? Pressure is the thrust or a force. Thrust or a force which is acting per unit area. Acting per unit area. Thrust or force acting per unit area. And why it is known as thrust? The reason of the word thrust means thrust is the force which is acting normally. Thrust is the force acting normally to a particular area of object. Particular area of object. That is the difference between our usual force and the thrust. Because usual force, it is not necessary every time it should act. It is not necessary that it should act every time normally. It can be act sideways, it can be act horizontal, vertical, whatever it is. Thrust means it is acting perpendicular, always acting at the right angles. So that is what, when you talk about the pressure, pressure is the thrust or force acting per unit area. Small classes we have learned it is the usual We have learned it is the usual force. Actually, when you come to higher classes, we are learning little more simpler, that is force acting normally. So whenever you hammer the nail, you are not hammering this way or sideways or this way. We always hammer it perpendicular to. So on the basis of that, we are getting the equation pressure P is equal to, this is all what we have learned only. So revision. P is equal to F by A. Mathematically, pressure is equal to F by A. So you can write the equation pressure is equal to F by A, or P is equal to change in pressure is equal to change in pressure delta P is equal to delta F by delta A, or P is equal to dF by dA, because always in physics everything we are talking about in terms of a small area, then we generalize the equation. And pressure is a scalar quantity. Pressure is a scalar quantity. And which are the factors affecting pressure? There are two factors we have. One is force. And second factor is area of contact. First factor is force. Factors affecting pressure. First factor is force. And second factor is area of contact. Okay, children, how does these factors affect? So I just give you a simple exam. As you two people, yeah, you are going for a picnic on the beach shore. Okay, so usually when you walk on the beach, you can see the footprints of everyone. So majority girls, they are prone to wear the high heel shoes, high heeled sandals or whatever. The boys have a flat shoes usually. Okay, so my question is to you, among the boys and girls, whose sandal or whatever should be plunged into the sand? Plunged into means it has been making a huge pressure on that. Can you guess? When two girls, or some of you, two girls are going walking on the beach?
Shorter base.
Shorter ones. Okay. Uh, what about the girls, Anna?
No, ma'am. The one having the shorter base.
Shorter base. Okay. I'm asking the girls, is the high heeled sandals or flat shoes are giving more, what do you call, more sharp footprint on the sand? Anna, high heel or the flat shoes? Actually, this is correct. High heel. Okay. Okay. Can you tell me why high heel is making a huge footprint on the sand? Shivani. What will be the reason? High heeled is making huge footprint on the sand.
Less area.
Less area. Correct. So that is how. Very good. So that is how pressure is affecting. That means less area, greater the pressure. Lesser area, greater the pressure. And greater the force, greater the pressure. Okay. So force and pressure is directly proportional. By the time pressure and area is inversely proportional. So this is the factors affecting pressure. Okay. If you apply more force, you experience more pressure. But if you exert the force on a small area, pressure will be more. If you exert a force on a large area, pressure is less. So These all things are very, very applicable in our daily life. You see it. Yeah. We are talking about fluid mechanics. Suppose you are watering the plants. You are having a pipe. Can you tell me which usually in order to what do you call, you scatter the water. Suppose there is a grass court is there, you wanted to put the water. So usually what you do after connecting the pipe to the hose to the pipe, what you will do, usually you want to put the water on a large area. So usually what you do, suppose there's a lot of small plants are there, you cannot use the water so much pressure. So usually what you do, if you wanted to water the plants on a large area, small plants, will you pour the water so fast into it or slowly? What do you do, Gauri? Suppose there's a small plants are there, so many plants are there. Shall you pour the water exactly coming from the tank, or what do you do? Suppose you have a pipe in your hand.
We will cover the hole with
Ah,
hand and then it
yes.
will scatter the water.
It will be scattered. It will sprinkle. We sprinkle the water. Yes. So what actually you are doing? There's a scientific theory behind it, correct? So when you cover the pipe, actually what are you doing there? What are you doing, Punya? When you cover the pipe with your hand and then you sprinkle the water, large area.
Reducing the area.
Reducing the area, correct? So when you reduce the area, what happened? The water which is coming from the pipe has been high pressure. So because of this high pressure, this water will be scattered like a jet, it will be spread everywhere. So this is the fluid mechanics, how the pressure is related to it. So everywhere in your house, whenever you construct the house, they will make a large area pipe as well as small area pipe. For our daily use, you open the tap. The tap will have small area opening. But the water which is getting into the tank, we use a huge surface area PVC pipe. So this is plumbers. They are doing that because of they may not knowing the science behind it. They are only learning the job. That means if you wanted to send the water from the well to the tank, you have to use a huge surface area PVC pipe. And if you want to connect it to the small tap, which we open daily, wash basin, kitchen and all, we have to use narrow pipe. That is, they are learning by experience, but they don't know the scientific theory behind it. So actually, the scientific theory behind of construction or of this plumbing work is actually pressure. Okay. So we don't, when you have bath and all, we don't require a big pipe. We want a small pipe because we don't use much water for having bath, washing your face. Okay. So that's the difference between them. So that is the that is the importance. This is the importance of pressure in fluid mechanics. Clear? And area and force has a lot of things to do with our real life practical situations. Clear? Now in the next class, I am not going to start the new topic, we may not finish. So next class, because I know that we have today five physics classes sir has put. So we will be learn little by little, don't worry. So what we are going to learn, the next class, I will learn the properties of pressure. You have learned Pascal's law and all. Do you remember Pascal's law and all? So just have a revision of that. Then only we go to the viscosity and all that. Clear? So we'll meet in the next class. Thank you.